Good morning, good afternoon to each one of you. I'm Raman from India. We are about to begin the webinar for the title Developing and Deploying Digital Twins for Industry and Infrastructure. Next. The program runs like this. The presentation will be, the title of the webinar is Developing and Deploying Digital Twins for Industry and Infrastructure. The presentation will be made by Valentin, Vice President, ARC Advisory Group Europe. And this will be followed up by a Q&A between ARC and Vivek Gupta, the Assistant Vice President and Head Instrumentation, DCM Shriram Limited, Kota. And then after that ARC Q&A, we'll have an audience Q&A for about 20 minutes. When it's opened up for the audience, either you can ask the questions live or you have an opportunity to type your questions. So at the end of the presentation and at the end of the Q&A between ARC and Vivek Gupta, the moderator will unmute you and then you can also ask the questions live. So this is how the program will go on. I will still repeat this after the Q&A when presentation is over with Valentin and Vivek, and then we'll start on this. Then this webinar is a part of the Digital Transformation Council. The Digital Transformation Council by ARC Advisory Group provides an opportunity for people to connect, collaborate, learn, and share with peers who are digitizing and transforming the organization. DTC is restricted strictly to end user community. So this gives an opportunity for the end users to interact with each other, and then DTC members will get a free access to council library. They can also interact with the ARC analysts. They can also get a priority access to ARC survey reports. Presently, ARC has decided that the DTC members will get a free registration for the 2021 Orlando Forum online, and DTC members also will be able to view the forum archives for the next 3 months. Now we start the presentation on the webinar, Developing and Deploying Digital Twins for Industry and Infrastructure. And this will be presented by Valentin, Vice President, ARC Advisory Group Europe. Valentin, the floor is yours.
Thank you very much, Raman. So does someone give me the, oh yes, okay, very good. I have the screen. Presentation mode. All right, can everyone see my screen?
It's all right, Valentin, please go ahead.
Super, okay, thank you so much. So developing and deploying digital twins for industry or infrastructure. So we'll briefly have a look at definitions of digital twins, then their importance in the asset lifecycle management. And then I'll have a look with you at which digital foundation you will need to make this succeed. Because digital twin is one thing, but the organization is another, and you need both to make it work. And in the end, we'll have a look at the link between productivity and the human factor. So why will digitalization help, and when, under when conditions? ARC Advisory Group is a global technology strategy consultancy in the domains of industrial design operations, infrastructure, and cities. We focus on automation, instrumentation, IT, industrial IT, and we have a number of typical deliverables, amongst which we have market size and trends, best practices, strategies, and so on. So digital twins. There are many definitions around about digital twins, but most of them basically talk about the same thing. A digital twin is a representation of a physical asset that has a level of completeness and accuracy and includes context information that allows the user to understand its behavior and performance. And its refers to the physical twin. So we're trying to have some digital representation that helps us understanding how the physical asset works. And that context information is very important. Say if I tell you 20, then it doesn't really mean a lot. But if I say to you 20 degrees C, then suddenly it starts making sense. That's because of the context. So context information could be text-based. It could be a data model. It could be a description. It could be asset or engineering information, or it could be programming code. Or the other type of formalism would be a 3D representation. So 3D model or a point cloud model, something that like that, or a combination of those. And there are two possible interpretations of a digital twin. It could be just static text-based descriptions. And that is similar to, for example, the asset administration shell, as it has been published by Industry 4.0. So that's just records with information. Or the other possibility is it could be static or dynamic simulation models. For example, an operator training simulator. And you find those definitions also in industry. For example, in Shell and Exxon and other companies, they have similar understanding. Now, just a brief word about those data models. A data model is really a structure in which we organize the information. And ideally, that data model, that structure should be understandable by everyone, and therefore should be standardized across the enterprise. And even better, it could be standardized across companies. And that is why some companies are working very hard on making an international standard. Now, there are two usable data models. Well, there are actually a few more, but the ISO 15926 or SFIOS is one which is promoted by Shell, amongst others. And there is then the DEXP model, which is very similar. It's more used in chemicals. And there is an initiative now to make the two merge into one identical, unified, uniform model. Now, those models, they are basically an asset hierarchy, and they go into very fine detail until the instrument. But for some industries, such as chemicals, fine chemicals, life sciences, that may not be sufficient. You may also need some additional dimensions, for example, production phases or recipes, or maybe people and material resources, or transaction data. That kind of model is described, for example, by ISO 95. So there is a big advantage in having a uniform model, which is basically that people and companies can understand each other more easily and know where to find the information. Good. So this is an example. You see a point cloud. It looks almost like a picture. And you see that there are a few equipment highlighted in red. And the information about those red elements are described in text, in records on the right. So here in this case, it is a storage tank that is used to dissolve salt. And we know its capacity, and we know its design pressure, and we know its design temperature, and we know its diameter, and so on. So you see that the 3D information provides context to the textual information, and vice versa, if you like. That's an example. So let's have a look at asset implications. We are used to think of the asset lifecycle as a linear lifecycle that starts with planning and then design and then procure and then build and then operate and maintain and then retire and recycle. But in reality, it's not linear. It's actually a few circular iterative processes. So we call project performance management the section where we do design, procure, and build, and we may have some iterations. We may have some modifications. We need to do some redesign. We need to re-procure some stuff. So that's an iterative process where we try to optimize that trajectory to operational readiness. And the information that we've been gathering is being handed over to the operating asset, and then we enter into the asset performance management cycle, where we operate and maintain and try to optimize the performance of the asset until we may have a bottleneck, or we may have maybe something to repair or to review, and then we'll issue a modification request. And then in the asset portfolio management, someone will decide if there is capital available, if there is resources available, and so on. And when it's approved, when it's a funded project, it goes back into the performance management cycle. So we have 3 of these cycles. Now it's very important that that information flows properly for the efficiency of the collaboration between the owner-operator, between the engineering company, between the construction companies, and so on. It's also important that the engineering and technical information is handed over to the operations. And if we fail to do that efficiently, we can lose a lot of money. We can use up to 2% of CapEx by not being efficient there, because we're losing a lot of time in trying to find that information back once we need to do something about the asset. And once the asset is performing, we should make that information up to date. And if we don't, again, we're not efficient, and the cost of that inefficiency is very big. It's up to 2.5% of the CapEx, and the CapEx is a very big number. So we're talking about billions of dollars, whatever currency you're used to. And so what our position is that we need to manage the information of the asset over the life cycle, and we need to make those processes communicate. We need the project performance management to deposit information there. We need the asset performance management to keep it up to date. And also in the portfolio management decisions, we need that information. So we need a central repository where all these processes can go to get that detailed asset information. And as we'll see, we can use it further for building digital twins. So just for organizing our ideas, if we get back to that linear process, and we're building a digital representation of the asset in the first sections of the process, when we're making a new plant, that digital twin is not really a twin because there is no plant yet, but okay, it's a digital representation in the case of greenfield. And then we'll hand it over to operate and maintain, and we'll call it the performance digital twin. However, when we start making modifications and doing projects, we'll probably start a branch, a version which is almost the same, but it is different for those elements that are concerned with that project, until that project is delivered, and then this one becomes the performance digital twin. So we have sometimes 1, 2, or multiple digital twins in operation in a plant, depending on what situation we are in. This picture has been published 2 years ago in the Namur General Assembly by Dr. Otten from the company Evonik, which is an important chemical company, worldwide chemical company. And this diagram summarizes a lot about the way Namur looks at the digital twin, and I really believe it's insightful. So at the bottom bar, we find all those systems that most of us have in place. We have computer-aided engineering and DCSs and historians and quality systems and lab systems and asset systems and business systems and so on. And all of those contain useful information on the asset. So what this says is that we want to collect that information, and specifically only those parts that are relevant to the asset, and store them in a central place, which is the middle bar. And you see that that middle bar is built up of a few sections. It has a simulation model, the behavioral models, but it has also the, let's say, the engineering and the technical data. So those are those two interpretations that I talked about in the beginning. And these are organized using the data model. And Evonik is extremely active in developing that data model. That's what I mentioned to you, this merge of the DEXP and the SFIOS data model. And then, of course, you need to store that. So suppose we have collected all that up-to-date, accurate information on the asset in this central repository that we'll call the digital twin. Then we can actually much more easily develop all kinds of applications on top of that. We can use it for simulation and forecasting, for planning. We can use it for advanced process control, for KPI dashboards, for OEE dashboards, for predictive maintenance, for accounting, for decision support, for augmented reality. You can go on and on and on. And you can easily understand that it's much more efficient to create that basis once and for all, and then have much less work in creating those applications and maintaining those applications, because those data here in the center in the digital twin, these data are maintained. That means that if there is a change made in operations, it will trickle through into our applications, and all of them will be updated simultaneously. So this vision is, I think, very useful to understand. Good. So you see that we can do lots of things with digital twins, and we can create a lot of value. The value that will depend on a few things. It will depend on your objectives. So you need to go after those projects that deliver the value compared to the objectives that you've set. And it will also depend on the digital maturity of the organization. And that's a real requirement to unlock that value. So you need digital competencies among the people that are using it at a minimum. You need your assets, processes, and people to provide information in digital form. Otherwise, you cannot use it in a digital twin. You need to make sure that the information systems provide the quality and the quantity of information that are needed to base your decisions upon, that are needed to make good decisions. You need flexible ecosystems for agile supply chains. And that means that people need to be doing their work autonomously and independently. So in terms of organization and people, there will be less emphasis on hierarchy and orders, and more emphasis on processes and rules and performance goals, and making those people autonomous in what they do. And we should be thinking in detail about the latitude and limits we provide them within which they can operate, and give them that responsibility. This is something we see since 5 or 10 years throughout the industry. Digitalization makes that people work more autonomously in smaller groups, and basically management cannot always be there to say what to do in detail. So we need to work in a more global level, give some more general directives and skills, and then give them the responsibility to operate between those limits. So we need a culture of collaboration and open communication that is built on trust, which is not necessarily an easy thing to have. We need personnel that must be willing to review and adapt their behavior, because things are changing. Goals for the organization are changing. Maybe their job definitions are going to change. So we need people willing to adapt. And we also need them to be willing to be guided by data and facts-based systems. It's not about belly feelings anymore. It's about using the data that we get from the plans that we use to make decisions. Now, this subject, I could speak much longer about it, and I would be certainly willing to do that another time. For now, we jump to the conclusions, which are that if we want optimal performance of individuals and organizations, we need to work on competence development, and we need a mix of domain skills, but also IT and automation skills. But at the same time, we need social competence development. People need to be able to negotiate, to discuss, to communicate efficiently with each other and appropriately with empathy and respect. As there is more and more data gathered from people and what they do, then we need also to be careful about their privacy concerns. We can improve the quality of our production and the quality of our products, not only through process organization and skills, but also by teaching people which attitude and which behavior leads to the best results. So that helps. The human reliability is also a factor in total reliability and quality. There is always a lot of concern that those digitalization initiatives would make people redundant. However, our view, and this has been proven by now, that we need to use the people where they are best. We need to engineer them into the system rather than engineer them out of the loop. We need to help them with automation to unload their brains so that they can use their brains to assess if something is dangerous or maybe threatening, which a machine can never do for you. And so we need to provide them context for decision making, and we need to also give them meaningful messages. Their systems need to speak human-like languages. We need to combine resource and competence management to make sure that we have the right mix of skills and amounts of people. And we need to acknowledge that there will be a change in job identity in some cases. All that together leads to increased competitiveness. And we have seen in Europe that it really works. So companies that apply Industry 4.0, digitalization, digital twins, they do have increased competitiveness. They start growing again, and actually they start hiring. So it's really the contrary of what people are afraid for. More and more people are hired when industries apply Industry 4.0. So it really works. And then you could argue, yes, but if a few are more competent, then the other ones will lose. Well, that's not maybe 100% true. That's maybe not true at all, because we always tend to think that the total cake of revenue is constant, and actually it isn't. Because if we make products with higher added value because of their quality, because of their performance, then we can actually sell them more expensively. And that means that the total revenues of the industry goes up. It means that the cake increases in size, and so everyone can grow. That's really nice concept. So I'd like to also have a look at this from an economics perspective. is basically to tell you that it's not only me and it's not only my gut feeling that are telling you to take both the technology and the people into account. The economists, they have actually found the same. So if you look at the productivity growth, G, in this equation here on top, it's composed in economics from 3 factors. There's one technical factor. There is one which has to do with capital investment, that's the K. So that's management and systems, and that is CapEx. So that's the technology. And then, I mean, the IT technology. And then you have the green, the LQ, that's the human factor. So you see that the growth in productivity depends both on your capital investment and your technology and the investment in your people. So it's not only me saying this. And sorry, the total potential of growth is about 2%, so that's an average, of course. And the part of digitalization in there is about 2/3. So digitalization, digital twins, could be a real important factor in productivity growth of your industries. Now, the little graph here at the bottom, you can't probably see the detail, but it doesn't really matter. You see that it's just a point cloud and there is very little correlation between the 2 axes. The one axis is the digitalization degree. So that's on the horizontal, and on the vertical, you see the productivity growth. And you really see that there is no correlation between digitalization and productivity performance. So what is the matter here? Well, the matter is probably that the levels of maturity are variable. So it's not only a matter of technology, as we said on the previous page, it's also a matter of people. And so I believe that we need to be good in technology, but also in management and systems, and also good in how we prepare our people for digitalization and digital twins. And if we have all that in place, then we can probably become more productive. The other question is, will there maybe be a time lag? And that really depends on how you implement digitalization. I think if you're very efficient about it, very rational about it, then you do small experiments until you find something that really adds value to your company, and then you scale that up globally and very quickly, such that it makes bottom line impact. Basically, keep it simple and implement fast, then you get economic impact. There are many companies that tend to do too many experiments in parallel, and they don't scale up and they don't get the value. So to conclude, here are the recommendations and conclusions. The digital twins are digital representations of physical assets with sufficient detail, helping us to understand the behavior of those assets. What return can you expect from that digital twin? Well, it will depend on the quality of your information. If you use 3D models and simulations, make sure they are consistent with the basic asset information. So that information basis is really key. You probably need to start considering, what do I have already and what needs to be complemented? And which part of that information can be trusted, because that's also important to get quality results. And so you need to invest in making that information trusted and improve its quality and complete it, and you get paid back by the efficiency gains. One gain that comes immediately from making asset information more accurate is that the reliability of the plants increase and that the maintenance costs decrease. And that's basically just because you have better information at your hands to make maintenance decisions. So it's really important to have some data governance, some organization overlooking what the quality and the integrity of the data is. and that will create value in the digital twin right away. So think of building that digital foundation, work on the mindset and the culture, because these are essential ingredients. Make sure that you talk with people so that they understand their job identity is changing, their roles are changing, and then build that digital transformation upon that foundation. And that's what the success depends on. So that's it. I thank you very much.
Thanks, Valentin, for an excellent presentation and giving an overview on digital twins. I think we will now start the Q&A between you and an end user. Next slide, please. Yeah, Vivek, can you come on video, please?
Yes.
Can you switch on your webcam? We are able to listen to you.
Yes. Now, am I there?
Yeah, thank you. Thank you. Thank you, Vivek. Thanks for joining.
Thank you.
Thanks, Valentine, once again. Just hold on. We are going to have the Q&A started by Mr. Vivek Gupta, Assistant Vice President, Head Instrumentation. Vivek, before you start some questions to Valentine, can you please talk a little bit about DCM Shriram and what you are doing, and then can go on to Valentine. Okay?
Yes. Okay. Thank you. Thank you, Mr. Raman, and thank you, Valentine, for a good, insightful presentation on digital twins. So, as requested by Mr. Raman, let me just brief you about DCM Shriram. DCM Shriram is a 125 years old company which is existing in India, and we are in the vast field. We have the manufacturing plants in Uttar Pradesh, Gujarat, and Rajasthan states of India. So the place where I am working at Kota in Rajasthan, we have 8 plants over here. This is an integrated complex where we have our captive power plant. Then we have our fertilizer plant, one of the oldest private sector power plant in India. Then we have an vinyl plant where the output of the plants are used as an input to the other plants. So let me start with this. We have a chlor-alkali business where we produce chlorine, hydrochloric acid, and frackers. Then we have another plant which is known as the calcium carbide plant, where we use carbon and lime to produce calcium carbide cakes. And then we have the acetylene generators over there, where this carbide is mixed with the water and we produce acetylene gas. Now, acetylene gas from this plant and hydrochloric acid from our chlor-alkali plant, these two are taken to a plant called polyvinyl chloride plant, PVC. So where we produce vinyl chloride and afterwards its polymerization is done. So there the PVC is being manufactured by us. This kind of PVC manufacturing is of its own kind in India. And then the sludge which we get after the reaction of calcium carbide and water, where we get this sludge of calcium hydroxide, that is being used as one of the inputs to our cement plant also. And then we have one plant called as Fenesta Building Systems. There we have doors and fixtures. You must have heard about it. India has a lot of installations of our Fenesta Building Systems. And then we have another plant called as Shriram Axial. This is a JV between Axial USA and our DCM Shriram group. There we again use our PVC and we produce a lot of products which are used in medicine lines, in cars and automotive sectors. Then we have 3 sugar plants in Uttar Pradesh where we produce sugar. And we have another plant called as Shriram Alkali and Chemicals at Bharuch in the Gujarat state of India, where again we produce chlor-alkali. So these are the 3 manufacturing, we call the production units under the umbrella of DCM Shriram. Then we have Shriram Agro Business also, which is there. We are one of the largest producers of the seeds, and we have an office in our Hyderabad and some international places also. We do have our offices. So this is all in brief, and this is a family-run business run by three brothers, which is headed by Mr. Ajay Shriram, who is chairman and senior managing director. We have Vikram Shriram, he is our vice chairman and managing director, and Mr. Ajit Shriram, who is our one of the directors who are actually running the admin company. So this is all about our DCM Shriram group. We are doing a lot of CSR activities also in current pandemic times. We have taken a lot of activities. We have produced sodium hypochlorite, which was used as a spray in the various cities of the Rajasthan. We have given it to the nearby states also as a spray to stop the spread of the COVID-19. So let me start with the digital twins. First of all, thank you, Valentine, for a very brief and insightful presentation. It was quite interesting. I have noted down some few points so that we can interact for the larger benefit of the audience who are listening to us. The digital twins have garnered significant interest over the last few years as Internet of Things has become more and more pervasive. And what we can learn from your presentation is that actually the digital twin is a real-time linkage between the physical world and the digital world. So my question is that, first of all, just for the interest of the audience, that always we see that we should go for the digitization. Now, where one should start to get the biggest value in the shortest amount of time, and how one can stay ahead of the competition. This will be naturally a first question when we put up digital twin for implementation or for starting the project to the senior management. Mr. Valentine.
Yes, hello, thank you, Vivek. That's a good question. It's a good question which doesn't have a unique answer. And I'm saying that because it will really depend on the priorities of the company. For example, suppose we have challenges in our company with rotating equipment. So maybe our rotating equipment breaks down from time to time, and that stops the production. So the cost of that is very high. So in that case, it could be very useful to build digital twins of that rotating equipment, pumps and compressors and so on, and fans and these kinds of things, to monitor them and to predict their maintenance in order to increase that reliability and create more uptime. So that could be one strategy if that's your challenge. If your challenge is maybe the reliability of your supply chain, connecting your providers with yourselves and your clients, then maybe you may have a much more global view and maybe start much more globally modeling your supply chain. So your plants, you model them much more superficially, and you create a global model that ensures that those flows work properly. So the answer to the question is, look where your challenges are and start there where you can gain the most value in the shortest time. And so that is really also probably a good argument if you want to present it to upper management. You'll get probably more attention if you address a real company challenge, or if you are able to show that you can create growth by that digital twin, for example, by improving quality. So I would say it really depends. Look into your own company and see where you can make the most impact.
Yeah, Valentine, just to add to this, we have been hearing about industrial Internet of Things, artificial intelligence, machine learning, deep machine learning. A lot of things are coming up now. How do we connect all these things with the digital twin? Are they fall into same umbrella, or how do we connect digital twin to the industrial Internet of Things? Are they interrelated?
All right, that's also an interesting question. traditionally, we have instruments and controllers in our control system. So that's the way we used to work, which gives us information on the plant. It enables us to control it, but it remains limited. So the trend that we're seeing here is that we add IoT sensors on top of those instruments in the control system. So those are two different worlds, we could say. We can connect those IoT sensors to applications that run maybe in servers or in private cloud or in the plant cloud. We can augment it. We can augment therewith the information that we get from the information systems, and we can feed all that into asset performance management applications, such as provided today by ABB or by Honeywell or by GE. So those IoT will, in a cheap and fast way, complement the information that you have, make your information bases more rich, and will allow you to make more useful predictions about the asset. Sure, you get less breakdowns and you do your maintenance at optimized moments. Is that helpful as an answer?
Yeah. So suppose a digital twin project has to be undertaken by a company. So in your opinion, what all this company should consider? Because as I have heard your presentation, you somewhere told the digital maturity of the company. So is it like that the company who has not done the basic sensors, who are, we can say, the smart kind of sensors, if those are not available, they cannot go for a digital twin kind of a project. So how do we link? What, in your opinion, the company should consider before taking up a project of a digital twin?
Well, as you say, yes, you should consider the skills and the maturity of the people. So you should look at that in parallel to the technical project. And then from the technical perspective, you can start where you are, as I always tend to say. I would say almost everyone has an historian in place. So you have asset data, you have real-time asset data. You have an engineering system with technical information. So you do have information. The question is which part of that information you will use and which part of that information is trustable. So have a critical look at what you have and what you need to complement, and which part of that information needs to be improved in terms of quality, and then focus on, you know, those critical projects that you want to focus on. You want to focus on rotating equipment, or do you want to focus on the global supply chain, or do you want to focus on quality? So you will have to see what information you have in the areas where you are really interested. So be very focused and rational about it would be my recommendation.
So can we say that it's a better form of historian? Suppose we create a digital twin of a compressor or of a turbine, something kind of a thing. So are there any off-the-shelf solutions available? Because see, once we do this full engineering, we develop a digital twin of an equipment. Let's say an example of an instrument air compressor. Most of the instrument air compressors works on the same principle, same kind of thing. So are there standard off-the-shelf solutions which can help the companies to take that, and in turn of its development of the digital twin, lot of things, lot of problems will come right. As I have seen that this is a kind of a closed loop. You have a physical object, you are making a digital object, whatever you are getting the feedback, again it is being fed to the physical object, so as to make it a kind of an efficient asset. So what I mean to ask you is, can this historian kind of information in the development of digital twin, can it be stored somewhere else, so that for the benefit of the other developments it can be used?
Yeah, sure. Yes, there are all the off-the-shelf applications. Now you should not imagine that will work in 5 minutes out of the box, but these contain standard models for standard type of equipment. And you will have to train those models with the information from your particular plant or equipment. So the information in your historian will be used to tune, to calibrate those models. You need to calibrate them with, at least 1 year of performance data before they become really predictive. But once you have trained those models, then they represent really the actual equipment, and they can be used to do predictive maintenance. So it's not a 5-minute thing, but there are aids out there in the products available.
So do you think that in process industries, as you are telling about predictive maintenance, can it be used? Because nowadays, in the tougher time of pandemic, where there are thinner margins and everybody is looking for the optimization of their processes. So how digital twin can benefit the companies as far as the optimization of the process plant is being looked upon?
Well, until hearing a lot about maintenance and uptime and reliability, so that is about reducing losses, right? We agree. But you could also use the digital twin. Think of a process simulation model to optimize. So if you can optimize the process conditions, maybe you can reduce your energy and material consumption. Maybe you can produce more if you're lucky in a good market. Or so maybe you can produce better quality. So those models can be used to create optimal processing conditions and creating more profit. So yes, that's definitely possible.
And what about the safety? Because safety is of utmost importance as of time, because lesser manpower is available and the same throughput is expected from the manufacturing units. So how do digital twin help in safety?
Well, reliability and safety are related. So if we improve reliability, we improve safety at the same time. We'll get less accidents and incidents. And that is, of course, independent of the HSE kind of safety. Let's say tripping over a line in the plant, that has nothing to do with your digital twin, of course. But let's say the process incidents and the process accidents will be reduced by improving the reliability. Stuff will not break down, there will not be loss of containment, there will be no fires related to that, and so on. So that is definitely an aspect that has direct impact on safety. I think you could even be more focused in using the digital twin to simulate emergencies and prepare yourself for incidents and accidents that could even improve safety further.
So Valentine, just picking up that point of simulation, a lot of plants use simulators, okay, for the training of their operators, for understanding the processes in depth. So do you feel that digital twin will replace the simulators which are being used in the plants nowadays?
I'm not sure I understand that word. Say that again. What did they use? You said?
What I am trying to tell you is simulators are being used in the plants to understand the process. You can simulate the process and see what if. So do you feel that digital twins in the coming times will replace the simulators which are used in the plants?
No, these are digital twins in themselves. So they are already digital twins.
So means simulators
we probably need to make them a little bit more reliable, a little bit more accurate. On the contrary, they will more and more.
No, I can supplement it. The operator training simulators, whatever is used in the plants.
Yes.
They are basically, majority of them work in offline mode. Okay, it is not online connected. Unlike digital twin, when you are connected to digital twins for performance operations, it's online. That's the big difference between OTS and digital twin for a performance of a plant. So as such, digital twin is a continuous continuously tracking the information, tracking all the details, and then guiding the operator on a continuous basis. Whereas OTS is generally used for offline training. Very rarely, similar OTS is used as online connected equipment. So it is generally offline. It may collect the data, but the decisions are not given to the operator. So in the case of a digital twin, the digital twin can give guidance to the operator what way he can improve the performance. And also, I know that it can be supported by experts also. When you have a digital twin, it can be supported by experts from remote to support the plant. Do you have any more questions? Or if you have,
yeah, just last question, Valentine. If a choice is given to a power plant, and just taking a typical kind of a case, what would be the equipment to start with a digital twin, in your opinion? Suppose a power plant has to go for the digital twin kind of a thing. What would be that first single equipment which a company should adopt? So first to get the most benefit out of that. Your opinion,
Right.
please.
Well, the systematic way to look at it is which equipment creates the highest cost if it breaks down, and which equipment creates the biggest production losses if it breaks down. So that's the traditional way of looking at asset priorities. So you pick that equipment which has the biggest impact on your revenues. And usually that's rotating equipment, but it could be something else.
Okay. Thank you, Valentine, for a nice, insightful answers by you, which I hope our audience must have benefited. Thank you, Mr. Raman, for this opportunity.
Thanks, Vivek. Stay online. Thanks, Valentine.
Yeah,
As such, we don't see much questions on the screen. Can you go to that screen? So either the people can raise their hand, and then the moderator will unmute them. As such, there are no questions so far in that, because this is one concern we had when we conceived this topic for the webinar, because we knew that digital twin is still a picking up concept in India. So there are, as such, there are no questions written down. Has anyone, Rajkumar? We had one. You can just connect him on that. Okay. I'll mute myself.
Okay, we have a person, Sharad Agarwal, who raised his hand. Maybe I don't know what type of question he has. I can unmute him so that he can ask his question. Mr. Sharad, can you please ask your question, please?
Yeah, thank you. It was really a very interesting session by Mr. Valentine, and the relevant questions that were asked by you, Mr. Gupta, they were all great. So, as Mr. Valentine, you said that it depends on the relevancy of the processes, but still, for the beginners, how shall people start evaluating the digital twin process? What shall be the primary criteria?
To evaluate the process, well, so as I said, I think the important thing is to look at the critical challenges of the company. So that may be reliability, but it may be quality, it may be throughput, it could be different things. So I would start with the priority and then look at the equipment that are directly related to that priority. And at the same time, you need to look if your process and if your people produce digital information so that you can work with it. Do you have the information of that critical equipment in your historian, yes or no? And if you don't, well, then maybe you need to add some sensors, or you need to make sure that the instrumentation provides the digital information to the historian. That is the way I would go about it. And evaluate is really could ultimately be evaluate the value. So you should monitor the performance of the process today, and you should compare it with the process performance once you put the digital twin in place, and you should be able to see the difference.
Okay, thank you very much.
Yes, you're welcome. You can always get back to us with questions and we can treat them in detail if you wish.
So we don't have any more questions now from the audience. So we can wind up the session. If unless we have any question, we can maybe we'll wait for 30 seconds to have any questions or yeah. So thank you for the presentation, Valentin, and
Welcome.
we have actually next webinar, DTC webinar coming up in January, which is January 22nd, 2021. And the title is Industrial 5G Accelerating Digital Transformation. And also we have a global forum, virtual forum in February 8 to 11, 2021 in Orlando, which is the accelerating digital transformation in a post-COVID world. And this is free registration for all DTC members attending this webinar. So
Yeah,
thank you again.
Orlando, but it's not in Orlando, right? It's just in the cloud. it's virtual.
Yeah. Okay. Thank you.
Virtual summit.
Yeah. So thank you again, Valentin. We'd like to thank Mr. Vivek Gupta also from DCM Sriram for participating in this DTC webinar. We'd also like to thank Valentin, Vice President, ARC Advisory Group Europe, for the presentation. We'd also like to thank all the delegates for participating in this webinar. Finally, we'll thank ARC Advisory Group India team for all the logistics support. Please mark your calendar for the next DTC webinar. Thank you. Thank you very much.
Thank you. Thank you.
Yeah.
Thanks. Thanks, Valentine.
Bye, Vivek. Talk to you soon. Bye, guys in the Bangalore office.
Yes.